Hello everyone, I'm Wilson Hong from Model 3D ENEA team. I'm mainly responsible for technical support in France and the Benelux region. Today I'm gonna share a very simple but worth learning tip. That is how to refine and mesh a geometric runner. I prepared an example and I believe this will be helpful for your future work. So let's start with the demonstration. So now we are in Model 3D Designer R16 and here you can see the model for today. And the model here we have a code runner and also the parts. So today's goal is to finish the mesh refinement on the geometric runner. So here we are in step 2. Let's go directly to step 4 to generate the mesh. So before generating the mesh, the first thing we're gonna do is to modify the node seeding. So let's start with the node seeding. So here, the first thing we're gonna do is to define the global mesh size. So normally you would try a smaller number than the default mesh number. So perhaps we can give it a like 0.5 as the default for both the runner and also the part. And the check. Alright, so now we are able to edit the node seeding on the runner or on the part. So firstly, we start with the runner. So on the runner, it is preferred normally to use a even denser node size than the part itself. So first thing I'm gonna do is to select everything on the runner and use a smaller mesh size. So on the left, the mesh size we can use like try with 0.3, a smaller number. Alright, so now it is denser now. And now the important things are, firstly, you should take care of the node density around the melt entrance here. Here is the melt entrance. So it is recommended to use at least 24 node segments around the melt entrance. It's recommended. So if more than 24, that's of course acceptable. So let's see. So you can tell easily that this circle is composed of 4 segments, and each segment you got 7 nodes. So in total, you actually got 28 segments around the melt entrance. So that's quite acceptable. And if you insist to use only 24, of course you can do it. So we can select everything. You press on Shift button and select the 4 curves and give them 6 for each. Then finally you got 24 nodes around the melt entrance. But I prefer to keep it denser as the default we made in the beginning, 7 for it, so that we have a identical mesh size here and also down here on the other feature lines. Alright, so the second point, the criteria around the gate is also very important for a CAE analysis, for the molding simulation analysis. So it is also 4 feature lines around the circle, I mean the gate. Okay, so it is also 4, but each curve you got only 3 segments, so that's quite not enough. The criteria for this one for the gate is that we recommend to use at least 40 nodes, 40 node segments around the gate. So we got 4 feature lines. It means that we need to use 10 for each at least. So now we got 40 around the gate, 40 nodes. So that's good. But now we can tell very easily that we have a size gap between the gate circle and also the feature line, between the between the gate and the feature line above it. So here you got actually 4 feature lines with less density than node density. So we need to also adjust the node density in order to make the change of the mesh size smooth. Okay, so for this one, you can firstly use a larger number of the segments. So let's use 15 for then, but you still observe this gap, of course. And what we're gonna do now is to use the biasing type to help us to finish it. So for biasing type, you can try either linear, exponential, or sometimes you may use bell curve to help you to make the change of the node size smoother. So here in this example, I would try with exponential and with a factor of 1. So let's see what's the result. So with the factor of 1, for this curve, the performance is quite well, the result is quite acceptable. This one is also okay because they are identical. This one is also the same. But for this one, you can see that the biasing direction is totally the opposite side. So it means we need to add a minus on the factor itself. Then it becomes the same. So now we are almost finished with the node seeding part. Okay, so we finished with the runner, but how about the part? So on the part, you can tell easily that on the gate, you also have a feature line. So I will do the same thing to it in order to make then have the same node seeding condition. So I would give it 10 for each. So now you got 40 around the circle for the feature line. Then that will be better for the smooth the change of the mesh size will be smooth. Okay, so we finished with the surface mesh, I mean the node seeding. And the second thing we're gonna do is to change the settings for the solid mesh. So for the part, usually we would try with 5 layers BON, and you can use a larger number for the offset ratio. And for the runner, because it's a geometric runner, so you need to change the settings in the geometry meshing instead of the curve meshing. So we switch to runner, and we also give it 5 layers BON and 2 for the offset ratio, which is also recommended to always use 5 layers BON for the runner. Alright, so we finish with the setting of the solid mesh. Then we can generate the mesh. Okay, so let's go directly to the end. Okay, so now we are finished with the mesh generation of the geometric runner and also its part. Alright. So finally, here we have a short summary. Do take care of the minimum node segments on the meld entrance and also the gates. So here for the meld entrance, node number above 24 is recommended. And for the next page, for gates, it is recommended to use more than 40 node segments. And on the other hand, when you are dealing with the fan or edge gates, it is recommended to use at least 7 segments along the thickness direction. So I think that is all for today's session. Thanks for watching. If you have any questions, please send an email to support.eu@modec3d.com. Finally, if you like this video, don't forget to subscribe to our channel. More videos will be on to help you to improve the skills in Modec 3D. Goodbye.